Okay.
So,
So the first part, there wasn't really any math, just knowing which formulas and what to use when.
uh-huh.
Um,
And really, even in the next part, if we're using that Excel sheet, there's not a whole ton of math either.
yeah.
I mean, there's a little, but actually, there's nothing. All of it is in the Excel spreadsheet. Oh my goodness, this is the best assignment ever. Okay, maybe not the best, but
Okay. So the first problem is find the proportion of those surveyed who have been in an automobile accident in the last 5 years. So
let's see. It looks like
67.99 or 0.6799.
I'll be honest with you, I didn't actually calculate anything. I was just checking to see if it was in the Excel spreadsheet. Because, I don't know, maybe that would just be too easy. That would be great, though. Okay, so
Okay, where did that go?
yeah, 67.99.
Yeah, 67.99%.
Mm-hmm.
Okay.
So the requirements. Bernie, do you already have the Excel sheet up?
I'm pulling it up right now.
Okay, because you enter in the 684 and the 1006, and it just pops up hypothesis test requirements, the confidence interval requirements, and everything.
Okay, so I'm going to edit. I'm going to change my X to 684, right?
Uh-huh.
And my N to 1006. And then just let it take over from there, right?
Yeah.
Okay. So, check requirements, construction, and confidence interval for this data. Well, they're both met, right?
Yes. They are both met.
Okay.
Oh no.
Margin of error at 95.
That's not on there either.
Yeah.
I was really hopeful, but that's okay. Let's see, so the margin of error. I guess we need the probability applet, unless you have it memorized, but I don't.
Wait. Margin of error.
Uh-huh. Well, we would just need the probability applet for the corresponding z-score,
Oh,
which is 1.96. I should remember that, but
okay. Yeah, that's okay. So yeah, 1.96
Do we? So we do the margin of error formula with a previous probability, right?
Well, it should be, yeah, it should be one.
Okay.
It should be your probability. So 1.96 times p hat times, or 1.96 times the square root of p hat times 1 minus p hat divided by n. Right?
I'm not sure. I'm looking at a different spot. Let me see. Okay, yeah.
Okay.
I was just
So,
I was looking at the mismatched one. So 1.96 square root, and our previous probability was 0.6799, right?
yeah.
And then our number is 1006, the n. So then that would be 0.029 or 288.
The ghost of the dwarf king. I think that wasn't a thing. How the heck did you get up there? Stop that.
Okay, did you get 0.0288, right?
Yes, I did.
Okay, and that's what it has on here as well.
Yeah, same question. They're the same answers.
Okay, construct and interpret the 95% confidence interval. Well, going to be 67.6799
Yeah, the ghost of the dwarf
plus or minus 0.0288, right?
Um, yes. But the confidence interval, I think, it's on the Excel sheet.
Mm-hmm.
Let's see. I'm curious.
Yes,
Yeah.
they've got to 3 digits on the Excel sheet.
Yep.
It looks like the homework carried it out to 4.
But we can you can just change that on Excel. If you just click on that cell, there's
Yeah.
a there's an option to increase the number of digits that goes out.
Okay. So what to next? How many
So
questions should you survey if you want a 95% confidence interval with a margin of error of no more than 0.015?
well, you would want to use the formula that's right underneath the margin of error formula that has a solve for n. And I got that we would want 6,322.
I'm getting up there.
You 6,000?
Yes.
I got 4,268.444444. So
Oh, sorry, I did the wrong margin of error. I did the wrong margin of error.
okay.
Let me change that real fast. So, sorry, what did you get?
I got 4.268.44444. So 4,269.
See, I just did it again and I got 3,716.
Okay.
This is for part E, the sample size, right?
Right. So we're
So,
going to do 1.96 divided by 2 times 0.015 and then all that squared, right?
Close. No, we want to do the z-score over the margin of error squared times the former probability times 1 minus the probability.
For the number?
Yeah. So the one that
Because-
we used would be if we didn't have a prior estimate of the probability. I think.
Do we have a prior estimate of the probability?
We used it. It's the. I thought so because that's what we used to determine the margin of error before.
No, I'm going over there. I don't want to know how.
Okay. Because see, I did the n equals z-score over 2m and then squared. That's what I did. Okay, our p-hat is 0.6799,
But
but we'd need a p. Do we have a p?
I guess not. So okay, so I guess I guess my question then is when we formulate the margin of error then, can we use the p-hat instead of p?
Yeah, because on this one it says when you don't know it, you do the 1.96 times the square root of p-hat times 1 minus p-hat over n. That formula.
Okay.
M equals z times the square root, and you can use p-hat. Where is it? Oh, I just lost it.
I just want to explore first. Because I'm not. No!
Let's see.
Why did you bring me all the way back here? That's mean.
I don't know.
Yeah,
Because I'm looking just at the beginning of section 3 from the reading, and it all
yeah.
makes.
What?
I'm looking at the beginning of section 3, and it all makes sense except for the formula for margin of error, how we just used p-hat in place of p.
Yeah. If you go to section 2.2, confidence levels, it says when p-hat equals x over n, you can use p-hat minus z-score square root of p-hat times 1 minus p-hat over n, and p hat plus z-score times the square root of p hat times 1 minus p hat over n. Do you see that in 2.2?
Yeah, but that's to calculate confidence intervals.
Right, and that's what we just... I guess I'm confused. I thought you were talking about what we did the problem before on, like...
No, I meant part C.
Yeah.
Oh no, sorry. Part C. Where am I? So part C, we're determining the margin of error for the 95% confidence interval.
So your confidence interval would be your p hat plus or minus this. So
Yeah.
your margin of error is still going to be the same. Does that make sense? Kind of.
So our margin of error is going to stay the same for E, for part E?
No, our margin
Right.
of error is going to go down to 0.015.
Right, that's what I thought.
Right. And since we don't know a previous p, we would use n equals z-score over 2m squared. So it should be 1.96 divided by 2 times 0.015 and then square the whole thing.
Okay. I'm just... No, I get that all the way. I'm just confused on how we can calculate a confidence interval than if we don't have that that previous probability before.
Well, yeah. All it says is to find a confidence interval for one population proportion P, we follow the same pattern as was done in the estimator for U in the lesson titled Inference for One Mean, Sigma Known. We start with the point estimate of P, and we add and subtract a certain number of standard deviations from this value. The point estimate for P is P hat.
Mm-hmm.
You might want to review the mean and standard deviation of random variable P hat in the lesson on describing category data proportions. Traditionally, people have used these equations to create a confidence interval for the population proportion. So basically it's saying where your p hat is x divided by n, you can use this formula. I don't know if that helps at all or makes any sense.
I'm just talking specifically about the margin of error stuff. I understand with the confidence intervals.
Yeah.
I understand that just fine, how we can use that, but it's just when it comes down to the margin of error equations that they give us.
Okay.
So if you go down to section 3, that's just where I'm looking.
Okay, let me go down to section 3. Well, so you're talking about the m equals z score times the square root of p, 1 minus p over n.
Mm-hmm. But then you go farther down and it has, if you have no prior estimate for finding the sample size, you can use this other equation, the n equals z score over 2m.
Yeah.
Squared.
And we don't have a prior estimate, so that would be this would be the formula.
Right. But so with the original one, why can't we just do, for instance, the square root of n? I can't rearrange that in my head quite, but
Okay, I guess I'm not following. I'm sorry.
It's okay. We can just move on because I'm I'll be confused about it, and I'll just have to accept it. It might be one of those things.
Now you're interested in testing a claim that over 60% of all students have been in a car accident within the last 5 years. Use the same information as above and use a level of significance of 0.05. So the null hypothesis is going to be HOP equals 60.
Percent.
And your alternative is going to be HAP is greater than 60, right?
Uh-huh. Well, is it going to be greater than 60 or greater than 0.6?
Okay, yeah, greater than 60%, but greater than, yeah, 0.6.
Okay.
So our z-score, since we have a previous known, right?
Uh-huh.
You're going to be 0.6799 minus 0.60 over square root of 0.601 minus 0.60 over 1. Oh,
I just took mine from the Excel sheet.
you just took yours from the Excel sheet?
Yeah. Maybe I should figure it out, but actually, let me just make sure that is the right thing.
Now let me do the long math and see what I come up with.
Value minus mean.
You found a challenge for me. What? This. I like challenges. Hey, you and me on a captain person. So you?
Okay, I got 5.173.
See, the one that shows up on here is 5.174. So I wonder what the difference is.
Well, if you take it all the way out, I have 5.17297211129.
5.17 what? Sorry?
5.17297211129.
Hmm. Oh, I know what it is. I knew what it was.
Jack, where did you find the dog? Dog? The dog? Yeah, a dog.
Okay. I don't know how to get it to change by one decimal.
Okay.
Stop making that thing go up!
And the p-score is insanely small.
Yeah. 1.14 times 10 to the negative 7th, I think.
Yeah.
So I would say
So,
that alpha's bigger than that.
yeah. And so basically reject the null hypothesis
Mm-hmm.
and basically say that, yeah, more the percentage of students who've had a car wreck in the last 5 years is greater than 60%.
Mm-hmm.
Right?
I think so. So our null hypothesis was, yeah.
That it was 60.
So yeah, greater than
So
60.
shall we?
Yeah. Should we start the quizzy thing?
Sure.
I'm sorry, Bernie. I really feel out of it.
No, you're fine. You probably feel like I did last week. So,
Can you share diseases over the phone type thing?
I don't think you can get anything over Skype.
I don't know. Maybe there's a Skype virus going around.
Okay. So, question 3 is p hat, right?
I think it's P because P hat is a point estimator of P. And because
True population. Oh yes, true population is p.
okay.
For one population.
Okay.
Shh. Okay. N equals 100, P equals 0.25, and P hat equals 0.10. Um,
So confidence interval, we want to use P hat to determine if the requirements are met, right?
Let me see. Confidence interval is N P hat is equal to or greater than 10.
And then hypothesis test is N times P greater than
Right.
or
So
greater than or equal to.
P hat.
So both 4 and 5 would be true because 100 times 0.1 is 10, and then 100 times 0.2. Oh, wait. Hold on.
Yeah, but we have to do the second one too.
Right. Which would be 100 times 1 minus 0.1, right?
Okay, so
Which gives us 90.
right, so the first one is true. 4 is true.
Okay.
5, I think, still has to be true.
I think so too. I'm checking the second one just to be sure, but yeah, it's true.
Okay.
A study of first-degree murder trials were conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 defendants were found guilty. Use this information for 6 through 8. Sorry, I had to read it in a deep voice because it started with first-degree murder trials.
Okay, so Our p hat is 0.750. Is that what you got?
Yep.
95% confidence interval is 0.640 and 0.860.
Yep. Decrease the sample size from if you increase it from 60 to 80. Okay, so increase it. What do you expect to happen with the confidence interval?
Well, let's see what happens.
I'm not sure. If we increase the sample size, we're going to decrease the proportion. Which would mean that we're going to decrease the confidence interval.
I believe so. Let me see. 217. Decrease, yes, because if you do the math, it actually goes down.
Okay.
Are you here?
Okay. Hypothesis test, and p equals 1/2. So what is the smallest number n can be?
How did you get over there?
Okay, so
Did you go on this thing? What? Did you go on
10, 20? Is that what you got?
For that first one, yes. For the second one, let me.
Okay. So 20.
That is exactly. Yeah.
I got 20 and 100. Is that what you got?
I haven't done the second one yet.
Okay.
Yeah, it would have. Would it? Yeah, it would have to be because of the
Because it'd be 0.1 times.
Yeah, exactly. 0.1 times 10. Or yeah, 0.1 times 100 is going to be 10. Yeah. Okay. The next question is good water quality. About 60% macro invertebrate water quality indicators historically associated with good health. The researchers suspect water quality in the area has decreased. Okay, so the conditions for the hypothesis test. I'm going to plug this into the Excel sheet. And hypothesis test conditions, according to Excel, are met.
Yeah. Okay.
Okay.
What is P?
P hat or P value?
Yes, what is P hat?
P hat, I got 0.475.
That's what I got as well.
Okay. And then test statistic, I got negative 2.282.
Okay. Let me check on that real quick. So Z-score.
I'll be right back, Ernie. I'm just
Okay.
grab something.
Okay. And you said you had negative 2.282?
Yeah.
Okay, that's what I got as well.
Okay. And then the p-value I got for that was 0.011.
Yes.
Okay.
So we're
then-
going to reject the null.
Mm-hmm. To say that the water quality has decreased. Right?
Okay.
So there's sufficient evidence to conclude the water quality in the area has decreased.
Yes, the first one, there is sufficient evidence to conclude that water quality in the area has decreased.
It always throws me off when they're all so close to each other. Oh no.
Oh no.
I forgot to answer question number 3.
Oh.
That's embarrassing.
I was like, oh no, I got 100. What? Oh no.
That's okay. Well, cool.